So we have Dr. Faulkenberry here. He used to be a faculty member in my department. Recently, he accepted the post as director of Center for Undergraduate Study and Creative Activities, also faculty member from Department of Psychology and Special Education. So today he's going to talk on Introduction to LaTex, very useful software.
Okay. Well, thank you, Yellen, for the introduction. Yeah, so this is very much an introductory talk into LaTeX. The way that I pronounce it is LaTeX. There's no X there. The standard being set by Donald Knuth when he invented TeX some 25 years ago. It's very, very strange as to why it's pronounced that way, but that's the way it is. Some people will call it LaTeX. I think the answer probably it should be LaTeX, and here's why. This was developed by someone named Leslie Lamport, and so La comes from the first two letters of her last name, or his last name. I'm not sure what anything about that, but so we can call it LaTeX. But I'm going to call it LaTeX because that's what I've always called it. This is a program that has been around. Was coming into this with this preconceived notion that LaTeX is still this new thing that everybody needs to learn. And then I realized that I first learned LaTeX. I was interested in this as an undergraduate at Southeastern Oklahoma State University. And so I had a few professors that used TeX and LaTeX, and I said, so how does this work? And nobody would tell me, and so I dove into it and downloaded some programs and got home with it and couldn't do a blasted thing with it because it was such a completely different way of looking at creating a document. There was no GUI. There was no thing to point and start typing. It was just a compiler. And I had a little bit of programming experience, but not enough to really do anything. So it was a very, very hard row to hoe. But nonetheless, I learned LaTeX in about 97 or 98. Now that's been 13 years ago. So LaTeX is at least 15 years old because it was around before then. So nonetheless, LaTeX is quite established. LaTeX is the standard of typesetting for anyone planning to publish in mathematics. It's becoming more and more of a standard for people who do computational things in experimental psychology, etc. For example, there's one journal called the Journal of Mathematical Psychology. It's full of mathematical formulae. They accept LaTeX as the primary source. They actually don't like Microsoft Word. And I don't blame them. I don't like Microsoft Word either. It's quick if you just want to type up a note, but let's say you've got a piecewise defined function with 3 levels in it, and you need to have some formulas like zetas, and you've got maybe an Euler feed function thrown in there. First of all, getting all of that to look right in the document requires a tremendous amount of pointing and clicking with the mouse from the little equation editor. And second of all, forgive me, but it just looks like crap when you end it. There's just no way to make it look good. And yet you see these wonderfully produced textbooks that have all these formulas in such nice, perfect italic. How do they do it? They do it with LaTeX. LaTeX makes your life better. I feel like I'm trying to sell something on late night TV now. If you want to take it as such, you may. So the way this talk today is going to work, you may have heard upon mention here that we are going to do a 2-week series on this. The purpose of today is in the time that we have, we are going to cover the basics of LaTeX. What those basics are, we'll talk about in just a second. But they're the things that you need. They're the things that I wish I had known when I got that first copy on a floppy disk. Okay, I'm starting to date myself here. I realize this, but when I got that first copy, these are things I wish I had known. All right. Now, probably next week, what you guys are interested in is what's going to drive the topics for next week. So I want you to be thinking about as we go here, oh, that's really cool, but can it do this? I want you to present a challenge to me, which I will try to rise to the challenge of. As I said, Dr. O already has one challenge, and you can be sure that we'll talk about that next week, but I would like to see others as well. And if you don't give me any challenges, then I'm going to tell you what's interesting to me. All right, so this is all about you, but if you don't tell me anything, then it has to be all about me. So anyway, with that, we're going to talk about LaTeX. Now, the absolute best way to learn LaTeX would be if we were all sitting in front of a computer. Okay? And as I can see, we have very many computers sitting in front of us here. The standard mathematical computer of a piece of paper is what it looks like. So, trying to learn a computer language by listening to someone talk about it is probably the most inefficient way to do it. what I'm going to do is I'm going to go through some slides that have screen captures from my computer as to what the code would look like, and then what it would look like after it was compiled, etc., until you can get the flavor of how it works. Now, don't write anything down, because I have a very nice full-color set of slides directly from this talk that I will give you after the talk. Okay? Although I probably don't have enough copies for everyone, but I can email it to anyone that asks. So, you think we got enough?
I counted.
Okay, yeah, we got 20 copies or something here. Okay, that'll be perfect. So, rest assured that at the end of the talk, you will get all of the how-tos with this, with the slides. Okay, oh, first of all, this presentation was done in LaTex. So if you want an example of what can be done with LaTex, just watch what we're about to do. This is nothing more than a PDF file produced with LaTex. So, let's see if we can get this to work. There we go. Our things that we're going to talk about. We're going to get started. We're going to talk about the general ideas of LaTeX, how it works, and then we'll get into some specifics. How do you present tabular material, like in tables? How do you present figures? How do you do mathematical typesetting? And then maybe just a little bit more at the end. So those are the very basics. Okay. So getting started. Well, to get started, probably would help if you had LaTeX on your computer. Okay. Now, how many Mac users do I have? Slowly changing the world, although I'm not changing anything with either of the two of you. So, if you have a Mac, this is incredibly simple, and everything that you'll see up here is an example of me working on my Mac. But if you're not so fortunate to have a Mac, there is also plenty of ways to do it on Windows. These are the particular places that you can go. What I have done is LaTeX comes in many flavors. Okay, there's things that we were just talking about a second ago with art here. So CTEC, Tech, MICTEC, MacTeX, all kinds of other stuff. All right. What I use on my Mac is something called MacTeX, and this is the address that you can get it from. This is a complete distribution. It's about 1.2 gigs, so be prepared to let it download for a while, but it is very large, very big, and will do just about everything you would want to do. On the Windows side, there's something called Protect. Okay, you love the pronunciations of these things, right? And I've never used Protect, but it is apparently somewhat comparable to MacTeX. Not quite as big of a download, but this will include not only the stuff to make LaTeX work, such as the executables, the files, all that stuff, but also a graphical user interface. The one on Windows is very busy looking. It's called something like Technic Center or something like that. But nonetheless, it's a basic graphical user interface for any kind of programming language if you have any familiarity with that. So anyway, the interfaces are different, but it doesn't matter whether you're using a Mac or a PC. What I'm about to show you works regardless of your platform. Anybody that uses Linux on a regular basis out here? Oh, okay. Well, if you use Linux, you already got it. So there's the thing about that. It typically comes with most Linux distributions because it's originally an old Unix thing that you would do at a terminal, which is what the computers were like when Eileen and I started graduate school a few years ago. So anyway, so you install LaTeX, and here's what blew me away. I wanted to start a LaTeX file. This is what you start with. Doesn't look like much, does it? It's a blank piece of paper, essentially. Okay. The thing that is now different that wasn't available when I was doing this, before you would have to get in and do some sort of, use like an editor like Emacs or Vim or something in Unix and just start typing stuff, and you had to know what to type. Now, with the advent of these nice GUIs, like this is from MacTeX, for instance, this is a program called TechShop. If I want to start a LaTeX document, I can just click over here and hit LaTeX template, and I'll get something rather full up on the screen, like this. Looks like a bunch of gibberish right now, but actually what's included right here is everything you need to make something work in LaTeX. All right. Now I'm going to point out a few things. Ignore the stuff up here. Ignore this stuff. Notice that there's a section for title and a section for author. Now that was in the template. It certainly didn't say my name or my title. It just had a generic thing. So I can start with this template that's given to me in my program and go in and change the title and the author. And then I just put some sample text down here. Okay? And I'm just going to see what it looks like. Well, how do you make it look good? Well, it is a compiled language. That means you start with a bunch of code-looking stuff, but then you have to somehow compile it into a usable, readable form. And so that's the purpose of this little button up here that says typeset. There will be something similar in whatever program you're using. That's the compiling process. And after you compile, you get something that looks like this. It's nothing more than a PDF page. Okay? Now, depending on your flavor, you might get a PostScript page, although virtually no one uses PostScript anymore. Most people use PDF outputs. But let's just say you're working with PDF. You get something like this. Here's your title, here's your name, here's the text that you typed. Nothing to it. You didn't have to do anything with the margins. You didn't have to make this all caps. You didn't have to change the font size. LaTeX did it for you. Okay. Now, it may seem difficult, at least at first to consider, how this could be an easier process than going into Microsoft Word. Let me give you an example. Let's say, there are many graduate students here. Let's say you're working on a master's thesis or a dissertation. What is the biggest worry that a graduate student has about their dissertation? It's not the content. You've got that. It's the rulers, right? It's over in the graduate school, somebody's going to check whether things match up, whether it's the right font, whether the right measurements on the margins, etc. If you haven't been there yet, you'll get there someday, okay? That's the biggest worry. Well, here's the trick about LaTeX. If you can set up what's called a style file for LaTeX to make all of these measurements automatically, all you have to type is your title and your name and your dissertation. You don't have to spend night after night trying to format, because as soon as you compile, it pops it out and makes it look exactly like it should. That's when the power of LaTeX comes, I think, over something like Microsoft Word. What's hard, though, is to get past all of this. So that's what I'm going to try to help you do. I'm going to try to help you understand what the different pieces of code here represent, and that they're really nothing scary at all, but they're rather just things that tell LaTeX how to make this document perform. Okay? So, any questions so far?
Yeah. What the minimum preamble say for typing a mathematical paper?
Okay. I will be happy to show you that.
Good.
So what Art is asking about is the preamble. That's this stuff before the Begin Document tab. See, everything that is typed is between the Begin Document and the End Document settings here, or the switches. All of this up here is called the preamble. Now, Art asked, what's the minimum you can get by with? And the answer is simple. You've got to have a document class, you've got to have a Begin Document and an End Document. You have to have none of this. You don't have to have a title, you don't have to have an author. As long as you've got the document class, and I'll talk about the document class in a second, and then the Begin and End Documents of environment, that's it.
You don't have to do any of those other...
No. Now, if you want some special AMS symbols, you have to use an AMS package, that sort of stuff. But the minimum way to get started on basic mathematical text is with the document class and Begin and End Document environment. That's all it takes. So, all right. So that's what it looked like after I compiled it. You get a little PDF page. And PDF is great because, I don't know if you ever had this problem where if you do something in Microsoft Word on your Mac and try to send it to someone on a PC and they don't have the right fonts, they don't look right. This is a portable document format, PDF. It doesn't matter who you are, whether you're opening it on an iPad, which is what my presentation is on, or a PC, or my phone, or whatever, it's going to look the same because it's nothing more than graphics. All right. So, one of the things you'll notice when you compile a document is you'll get a bunch of files all of a sudden. Maybe if you did this on your desktop, all of a sudden your desktop goes poof. There's a whole bunch of files on there. The minimum files that you'll get are these listed right here. First of all, this one I just called sample.tex, T-E-X. That's what I call source file. Okay, that's where I type all that stuff that I just mentioned a while ago. When I typeset it, I'm going to get the PDF file with it. It's going to have the same name as my source file, except a different extension. But I'll also get what's called an aux file and a log file. Now those are important, but they are meaningless to basic typesetting. You don't need to investigate those unless something went seriously wrong and you're trying to figure out exactly where it is. But basically you can ignore those files. The important ones are your TeX and your PDF file. Okay. All right. Another thing that you'll see is something called the console. The console is your friend. Okay. Here's why. One of the things that you'll do when doing LaTeX documents, especially in the beginning, is you will make an inordinate amount of errors. Okay? Why? Well, for instance, what if I typed begin document and I misspelled document? Okay? I didn't mean to, I just did. I typed and there it is, it's wrong. Nothing's going to typeset. You're not going to get anything out of it because that's spelled incorrectly. So how do you know that that error is there without having to look through every line in your document to debug? That's what the console is for. The console runs through a bunch of stuff. Most of this is meaningless, but notice right here, what does it say? LaTex. I do want you guys to talk to me about it. Yes, thank you. Yes, LaTex error. There's no line to end here, and blah, blah. So it tells me what line it was on, and normally, if I click on this, it'll take me right to my source file. I can investigate that line and see. Typically what happens is you leave out a bracket or you put in too many whatevers. It depends on the situation. But leave out a $sign, that kind of thing. So a lot of times it'll be a simple error, and it'll go ahead and give you a PDF document. It just may not look correct. Sometimes if it's really serious, it'll just stop compiling altogether like it did here. Okay. So that all comes from the console. So that's another thing that one has to pay attention to. And errors are inevitable. So on this slide, you know, there's a couple of common errors. We just kind of mentioned those. One of the, oh, hang on. I just pressed the wrong button. Come on. Uh-oh. Well, let me get over here to my, oh, it just completely went away on me. Hello. That was strange, guys.
Errors are inevitable, Tom.
They are in error, but apparently on iPads too. So let's pull that errors slide back up there. Okay, so I'll advance my slides from the iPad now.
Showed something, projector and something.
Well, everything kind of messed up on
projector
it.
messed up this morning, so.
Is that what's going on?
Probably.
Oh, that's not going to be festive, is it?
No, there's a chalkboard.
Well, that's not going to do much for this now, is it? Let's just try real quickly. Sorry about that, guys. You can do LaTeX without a projector, but I can't teach you LaTeX without a projector. So we're just going to start this back up and see if we can get it to work. Okay. So I think you just recognize my iPad, so we'll just let it come up here.
While this is coming up, didn't you create a style file for here when we were working on your dissertation?
No. I did for Oklahoma State.
That's right.
No, when I got here to work on my dissertation, I didn't have time to create the style file.
Yeah. Going through the document right here,
Mm-hmm.
maybe you can check and see. It's going through two different components right now. Yeah, sometimes you got to turn off and things like that.
Projector on right now. Those of you that are sitting under it.
It's making noises and it's blinking green.
Still blinking.
Still like
Yeah.
Okay, it's not going to do anything for me then until it stops blinking. Let's see if we got something at the... I love all the chalk on all the component cables over here. That's really effective for keeping connections secure.
Register your documents.
Okay, good. So let's... That. Now, what I'm going to do is count.
Yeah. Yeah.
Oh, we got something now. Well, how about that? Well, I apologize for that, guys. As we were saying with errors being inevitable, one of the things that you'll not want to do when doing LaTeX documents, and again, you're going to learn some basics of LaTeX here in a second, I'm just kind of giving you the overall picture of what you would have to do. What I tend to do is I'll write a few lines and then I'll compile because I want to make sure that what I've written is error-free. Don't write the entire document and then compile because I guarantee you there'll be 15 errors in there and tracking all of them down at the same time is difficult. So every 1 to 2 minutes is my recommendation that you go through, type, and then compile. Just make sure that that thing's looking the way it's supposed to. Okay? And then you'll have a relatively error-free, or at least relatively headache-free time. So, all right, so let's talk about some general material. Okay. So something that Art asked a second ago, what's sort of the minimal stuff that you have to have in a document? Well, the absolute number one thing that you have to begin any document is the document class declaration. So this is exactly the command right here. It's this / document class. And you'll notice it right here from my screen capture. It's got some stuff here. First of all, this thing in brackets is the article class that you're using. So typically you can use something like article, but there are other ones available. You can use one called letter, and it makes a very nice letter for you. You don't have to worry about the margins or anything. You just say letter, and it makes it look like a letter. It's amazing that way. When you want to do presentations, I use a class called Beamer. Beamer being the old version of a projector, a beamer, so that's where that comes from. And there's a book class. Okay? The American Mathematical Society has special classes, AMS Art, AMS Book, and they look decidedly different from the standard article and book. There are some experimental classes for doing APA 5th edition and even APA 6th edition now. So for my psych friends who are interested in that, there are article classes that take the worry out of APA formatting. You just type your stuff and it puts it right in there. So yeah, that's what has to be there. You can control the font size in this little, what's called an optional argument, and it goes in the little square brackets. This one is 11 point, you can change that to 10 point or 12 point. I think those are the three main options that you can use. You can change text size within the document, but there's a different way to do that in just a second that I'll show you. So anyway, that's the document class. That's what has to be on every LaTeX document. The rest of it is filler. Okay? Now, what's then the point of all that stuff underneath the document class line? Well, those are certain packages. So for example, if you want to use graphics in your document, you're probably not going to get very far with a very bare bones LaTeX file. But if you use the package called GraphicX, then you have a lot of graphics options at your command. You can use, if you want to use a lot of mathematical symbols that are beyond the standard LaTeX symbols, there's one called AMS Sim. That's again from the American Mathematical Society. Let's see, there's another one here. If you want it to be printed out on letter size paper, there's a geometry option from the geometry package that declares letter size paper, etc., etc., etc. The preamble here, which is the space between the document class and the begin document way down here, is where you say, I'm using this package, this package, this package, and this package. Okay?
So
Yeah.
when you download this LaTeX, so does this package go with
Most of the all of the common ones will be in whatever you download.
okay.
However, there are packages that somebody has written. I mean, this is open source software, so people are creating stuff for this all the time. Did I mention it was free? It's totally free. There's nobody that owns LaTeX. It's a community-driven open source effort. Sorry, I should have said that at the beginning. You want, say, a package, like that APA 6th edition package that I wanted. I had to download that. But then if I download it, I can use it, that kind of thing. So, now there are special considerations that you have to put it in the right place after you download it. It's beyond the scope of today, but it's something I can easily guide anybody through that's wondering. So packages are good. Packages are great. All right, let's do some basic formatting. Let's say you're working on a document and you want to have some heading levels. Okay, so the standard LaTeX headings are section and then subsection. What do you think goes under that? If you want another level of heading, subsection. It really does work that way. But I want you to notice up here in the code. Notice that I said \section. Again, most LaTeX commands are invoked with a \. Your editor will color them differently for you. I wanted to call my section general, and I wanted a subsection underneath that called header section. I compile, and this is what comes out. I get a nicely formatted general section header. Notice it's a nice bigger, bolder font. My subsection is numbered automatically for me, and then my text that I put in there. Again, that required no effort on my part other than saying what I wanted to call the sections and what I wanted the text to say. All right. Another thing that people often will ask about is, how do you invoke paragraphs? Seems like an easy thing. In Microsoft Word, you just hit enter and it goes to a new paragraph. It's not quite so simple in LaTeX because simply hitting enter won't necessarily tell LaTeX that you're ready for a new line. Okay, so there's a couple things you can do. First thing that you can do is, in your LaTeX source document, you type some stuff, okay? Then hit enter, but then hit enter again. If LaTeX reads a blank line here, it will automatically make that a new paragraph, okay? For example, if I do this and then I hit enter once, this will not be a new paragraph right here, okay, when I compile that. Because it's, with what LaTeX does is it reads to here and then to the next readable text, which is on the next line, but it doesn't see a blank line. It looks for a blank line in order to start a new paragraph. Now there's one other thing you can do. If you are formatting like an exam, okay, many of you will want to write exams with LaTeX, you put your question, you don't want the next question just directly underneath it, right? You want the next question to have some space underneath it for people to answer the question in. What you can do is a real slick little double backslash, which will end the line, and then it'll tell it to skip 1 inch down the screen before starting the new line, or 3 inches, or 5 inches, or even you can go all the way to a new page that way. So it's really easy as you're typing. You don't have to make the space yourself. You just tell it, I want to be 2.3 inches down the screen, or down the page, and it'll do it for you automatically.
You can also do V-skip.
V-skip and V-space, yeah, absolutely. I think I mentioned V-space here in just a second. Yeah, so there's some alternate ways to do it. You can do indentations automatically just using an indent command. If your style automatically indents stuff, like on exams, I don't want new questions indented. I want them flush to the left side of the page, right? So I can force a no indent there that will make it go over to the side. A really geeky way to do it is to, in the preamble, tell it that I want my indent length to be 0. And then I don't have to worry about it anymore. When it automatically indents it, it'll indent it 0 inches, which is not an indent at all, right? So there's a nice geeky way if you want to play with code. You can create horizontal space like this. To do this in my LaTeX document, I just simply did something like that. Notice it just pops it over. I can set vertical space like this with the V-space command. Yeah, Lynn mentioned the V-skip command. I don't use that one as much. You kind of, there's so many commands, you get used to the ones that you use and kind of forget about them.
So what does the V-skip do? Do you
When
do
you
like,
do V-skip 3 cm, it will give you 3 cm.
so it's this, it's
The
just like the
vertical skip.
V-space, it's just the V-skip?
Yes.
Yeah, basically has the same
It gives
effect.
you vertical space, 3 inches, 3 cm.
Yeah,
Okay.
yeah. So essentially it's interchangeable with V-space.
Okay.
I've seen one V-glue, which.
I have no idea.
I think, I got the impression it did some kind of vertical skip, but
Yeah, I don't know. I don't know.
I couldn't find it anywhere else except on the document.
I like this one. You can play with the fonts in here. Okay.
Oh,
First of all, if you want to italicize something, you have to enclose what you want italicized within a command called emph, okay, which is \emph. And so the word, the command would look like this, emph, and then I want to emphasize this text, okay. And then what it's going to do is literally do that to your text when you typeset it. It's just going to make that word italicized. Okay. You can bold it the same way. You use something called text VF. Okay. You can color it using a color command. You can make it look like a typewriter. Notice how this looks very different from the surrounding text, slightly so. That was what I used for that, text TT. Okay. And then of course one that's very useful sometimes is changing font size. So I want you to notice, reading across here, tiny, script size, footnote size, small, large, 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 etc., etc. And how you get those, if you ever want to do that, is literally \tiny, \script size, \, whatever word you see up here. If you want it really big, \large, all caps. Okay? So those are ways to control the relative font size within the document. Okay? Again, it's nothing more than typing one little command. You don't have to go up and mess with finding font sizes and all that stuff.
Do you have to enclose the text in braces?
The way I do it is this. I actually was talking to Eileen on the phone about this just yesterday. So if I have like some text here and some text here, but in the middle I want something really big, then what I do is I lose a little bracket and then I say large and then space. I don't have to enclose it, I just say what I want and then there's my text. And then I close the bracket. So what that tells is everything within this bracket is going to be with this font declaration. And so that word will be bigger in the middle of my text.
Yeah.
And there are other ways to do this as well, but that's one way that I have found that works pretty smoothly.
And this has been helpful, like if I do a test and I have a student who needs something larger, once I've done my test or whatever it is that I've done, I can just go in and type large and then recompile it and I have a copy for those students that need the accommodations.
Exactly,
I don't
yeah.
have to go through and change a whole bunch of stuff, I just type large and go.
One 6-letter statement changes the entire document for you that way. Yeah, it's really, really efficient. It's really efficient. Okay. We can do lists. Okay, if you want listed items, especially in presentations, it's often nice to have bullet points, as you can see. So the way that I would format this thing right here for you on text is literally like this. I put it in an environment. Okay, whenever you see a begin followed by an end, that's called an environment in LaTeX. So this is the itemized environment. Everything in here that's declared as an item will then be bulleted in an itemized list. It's not numbered, okay, but it is itemized. And so here, my bullets are little triangles. Depends on your style file as to what the bullet is. It might be a circle, it might be a triangle, depends on the style file that you're working with. Okay? In this Beamer class that I'm using to do this, they're triangles. Okay? They just happen to be triangles that are the colors of Texas A&M University Commerce. Don't know if anybody noticed that, but you can actually specify the RGB color code of your triangles. So, another little geeky thing that you can do. But you can also do numbered lists, especially if you want to do an exam with numbered questions. It looks exactly the same except for what? And an incorrect thing. Enumerate. Right, so this is the enumerate environment. If I LaTeX this, what error would show up?
There's no end.
It would say there's no end enumerate environment, right? Because it had to, if you say begin enumerate, it has to be concluded with end enumerate, and it says end document. So that's actually a little typo. It's a little quiz to give you, all right? But that results in a numbered list, just like before, except it's got numbers now instead of triangles. Now, one really kind of cool thing. Yes.
Nest enumerates?
Yes, you can. Okay, so for example, what if I had this and then down here I wanted another 1, 2, or A, B, or something like that? There are ways to do that. Simply after the first item, I would start another begin, end, enumerate environment and put what I wanted there. That would nest it into the next level. You can actually control what the labels are, but that's more advanced than I want to go into right now. In fact, I don't even know how to do it. So it can be done, just don't know how to do it.
Well, that printed the way you wanted, even though you had the wrong ending.
Well, because I did this in a different thing than this.
Oh.
I had 5 screens going on my computer, and they were different processes. So, yeah. It wouldn't have done the right thing if I'd left it like that. So. Yeah, it made me look better than I was. So. Questions so far? We're still doing okay on time. We're going to have to kind of speed it up a little bit. But you can do tabular material. Okay. If you're going to do a table, you enclose it within a table-type environment. Okay. The table environment is oddly called tabular, not table. Okay. Table's a little slightly different. I'll show you in a second. But let's say I said begin and end tabular. There's one thing up here that goes after the tabular, and that's the alignment declaration. You notice it says LCR? We think LCR represents?
Left, center, right.
Yeah, left for the first column, C for the second column, right justified for the third column, and you can see precisely down here that that's exactly what it does. Okay, the left column is left justified, center column is center justified, the right column is right justified.
You can also put triple C there.
You always put triple C, yeah, so center, center, center. Yeah. There are ways to make the column specific widths, etc., etc.
Just
Right.
tell
And
you
you can
3
put bars
columns.
between them too.
Yeah, and we'll see an example of that in just a second. When you put your table material, you just literally can write it like it is a table. The only thing is you have to put a little ampersand right there to tell LaTeX that you're going to the next column. And then the double backslash, of course, means go to the next line as it did before. So first line, bump, 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 second line, bump, 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 results in this little simple table. It has no bars or anything between it. So a lot of tables have grids. How do you do that? Well, you use the same environment. Here's a nice little stat table just to throw out there for us. How do you do that? Well, it's basically the same. Okay. Here's your begin tabular. Now I want you to notice something. What's that right there?
The vertical line.
It's actually an L. It's hard to see sometimes, right? This is an L. This is a vertical line. Okay? And I said something about that in this little comment out here. So this is an L, which means first column is left justified. This is a vertical line. It means it's going to put a vertical line between the first and second column all the way down. You can see that's what it does right here. Right? And then my last 4 columns are right justified. So I've just built up this table using just a simple command. I've got a left justified column, a vertical bar, and then 4 right justified columns. Now, to get the horizontal lines, between every place that I want a horizontal line, I put in the simple command H-line. Then I put my stuff, okay? These are my headings. Notice they're separated with ampersands. Okay? H-line, and then the stuff I wanted in my tables. Notice the H-line was only between the first and second row up here. There's not one between the second and third row. And that's how it shows up on the document. Yeah.
What's the purpose of the percent symbol?
The percent symbol is a comment. That's something like, one of the things that you should always do as a programmer is leave yourself comments in the file so that you know what you were doing when you go back to look at it. And this comment, for example, if I go back and look at that, I wouldn't have any idea that that was a vertical line as opposed to an L. LaTeX can tell the difference, but my eyes cannot. So I put a little comment here that that second symbol is really a vertical bar. So LaTeX doesn't read that part, it's just for the programmer to read. They're not required, but they're very helpful. It's called literate programming. So, all right. So it looks like we got a significant effect of X in this linear model. Don't know what the model represents, but there you are.
So you wouldn't need percent symbols in a preamble then, would you?
Not necessarily. Not
They
necessarily.
won't print anything in the preamble anyway.
Right, right. Now in your text, if you want to present a percent symbol, because I can tell that's where your question's going possibly, you would just do something like this. Backslash and then percent. That'll tell it to read the percent as text.
And it would print percent.
Suppose you wanted to, after, after the first column, second column, you put another vertical bar.
Mm-hmm.
And then vertical bar after next and next, and then central
Yeah.
bar.
Yeah, you could do it. Yeah, the only difference is up here, you would tell it that that's what you want to do. You would make all these C's instead of R's, and then you would put that little vertical bar in between each of the C's. That's right. Yeah, so you have full control. To the detriment, actually, sometimes we don't know what we want it to do. So we have full control over how it looks in the end.
And you can move this one like if you're doing an Excel or something within that to work with it?
No,
No? You can't?
not that easy. Yeah. There are ways around that I'll get to pretty soon, but it's actually very difficult to transfer from something like Excel into this. So that is one downfall. But I'll show you something that you can do with something similar to Excel. I want to mention real quickly. No, hang on, sorry. I went too many pages. Let's say you have a table and you want to put a caption on it. Okay? To do that, you have to do something that's technical to LaTeX. It makes no sense, but LaTeX is full of these, and it's something called a float, okay, or a floating environment. To label or number something like a table or a figure or an equation or something like that, you have to what's called float it, okay? The way you do that is you put it within a so-called floating environment. So you know I said a while ago, the tabular environment should be called what? Table? That's because table is a floating environment, okay? So if I want to do a table that's labeled and captioned, that's when I use the begin and end table declaration, okay? This itself will not construct the tabular material. It'll just put a float around it. And so what you get is a table that then has a nice, fun label on it. It would actually number this thing if I was using an article class or something like that. Does that make any sense? So that it's the idea of a float that is peculiar to LaTeX. It takes a long, I don't know, it took me a long time to figure out, so.
By it being called a float, does that mean that it might float within the text?
Yes.
So if you're doing tabular, it's going to go where I put it. But
Right.
if I do float, it's going to put it in a nice place.
Right. So LaTeX has a way to calculate what the nice available space is. You have some control over it. That's what these options H, T, B, P are. H means here, T means top, B means bottom, and P means, I forget. You can just leave off the H and T, like you don't want it at the bottom of the page, so you just say either here or at the top of the page. You're telling it to go one or the other, whatever's most convenient, whatever's most efficient in the document structure. LaTeX calculates it for you automatically. Sometimes you get a little ticked off at LaTeX for doing that, but yes.
Can you move the caption up to the above of the table?
There's a way to do it. I don't know what it
Right,
is.
I remember I had a hard time to do that.
Yeah, because the standard way to do it is put it below it. If you can ask the question, there is a way to do it. It just may not be something you want to do. But, hey, if you want that to be a challenge for next week, write it down. So, God, what am I getting myself into here? So.
Google.
All right, yeah, Google. Google's your friend. Okay. One thing I do want to mention is if you're using statistical software, I don't know, that's equally open source and awesome like R, there are things you can do within R that kind of mate with LaTeX. For example, there's this package in R called Xtable. So let me just kind of bring you through what I've done. What I've done is define an X list, just 1 up to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've defined a random normal variable. It's actually a vector of 9 things. And then I've defined a function based on X and Z. Okay? So basically it's a random noise function. And then what I did was I computed a linear model where Y depends on X and Z. And I wanted to see if X or Z was a significant predictor. So it's basically like an analysis of variance that you would do in stat class. I can do Xtable of the summary of that, and it gives me, within R, all the LaTeX code I would need to make this table, which is a very nice output table in a stats book. Okay? It did that completely within R for me. I didn't have to manually do any of this. I didn't have to copy any of the numbers, etc.
If you had the APA package, would it make the table in accordance with what APA likes us to with that command?
What you'll find with that is Xtable as a package does not do that. But if you are working within APA, you actually have the LaTeX code for this, so you can make any adjustments to that code to make it fit what you need to. But it's still less work than trying to just copy the table, copy all the numbers yourself. So, okay. Figures I'm going to go through real quickly because I want to show you the mathematical typeset. Figure is another thing that you do in an environment. You begin, you can do a begin figure. You can simply, the easiest way to do it is just use the include graphics command with your figure name. Okay? That assumes that the figure is in the same directory as your LaTeX source though. So if you've got your source here and your figure's off somewhere on another computer, it's not going to find that figure. You have to put it in the directory tree somehow. The way I typically do it is I have my LaTeX source and then a folder called figures. And I put all the figures in there and then I tell it that to go to that figures and then figure 1 JPEG. I can specify its height, all kinds of things like that. Again, you can see the handout in just a second to kind of play with this command. Another real slick thing that I've learned how to do recently is instead of specifying a definite height for my figure, suppose that I'm doing something on this size of paper. I don't know what the width is, but LaTeX does. It's something called text width. I can tell LaTeX to fill up this figure 80% of the text width, and this will do it. Width equals 0.08 text width. And whatever that text width is, whether it's this or this, LaTeX will scale the figure to be 80% of that. Every figure you see on this presentation is done that way. Some of them are 70% text width, some of them are 50% text width. I don't have to know what the actual measurements are. LaTeX keeps track of all that. Again, very efficient.
Question,
Yes?
if you're scanning something.
If I'm what? Scanning something?
You scan something and you're making out a test. You want to get that picture, put it in and blow it up or smaller.
Yes.
This would do it now.
Well, this doesn't do the scanning, but assume
No,
the,
after the scanning was done.
and you've got the JPEG file, then it will stick it into the LaTeX document for you.
And then you can get it bigger or smaller.
That's right.
Yes.
You control how big it is.
Okay.
So, now what you will run into, and you'll notice this here, if you really take a look at some of my graphics here, they start to get a little blocky. That's because the original figure was like this. And I blow that up to something like this, it only has so many pixels of information, and it's not quite as smooth as you want, so you can run into that. That's why making your scans as high resolution as possible is good. You really only run into problems when you're doing big presentations like this. On a paper, it's what they're like. Okay. Let's go on. All right, let's do some math and let's get out of here for today. Okay. Here's why a lot of people want to do LaTeX, and I wanted to wait till the end for this because it's the exciting part. Okay. Tell me how you could ever make Microsoft Word do something like this where you've got an alpha, a zeta, and a mu just so beautifully placed within your text. It can't happen. It just doesn't look that good. Now, if I did this on PowerPoint, it would be the same way. It would be sort of different font style, chunky, blocky, whatever. It would just suck. Okay? But now, if I wanted to type all that, this is the code that it would take. So I'm going to actually walk you through this little code snippet. Okay? LaTeX makes it very easy to add Greek letters like $alpha. Notice I put a backslash before the alpha. That, when you see the $, that's an environment. It's a math environment within text. So if I want to put the letter alpha up there, I say backslash alpha, and I'll make sure I put that in a little $, delimiters. Okay. zeta, mu, etc. I can even do equations, y equals x cubed. Here, I want the sum symbol. I want z to the j. Well, of course, that's z caret j, the way it's always been when doing math to text conversions. I want these little centered dots. Okay, Word has a hard time with those. The command C dots puts them right in the center. It's so easy once you just kind of get the idea of how the commands work. So in that little code snippet, I've got something that, I'm sorry, looks damn good, okay, compared to what I could have. It does take some practice, but there. How do you think beta would be created? What would I have to type to get that beta right there? $/beta. What if you wanted a capital beta?
You just capitalize the...
Capitalize the B on beta. If you want a fraternity or sorority name with the capital Greek letters, just use a capital first letter on the name, and it perfectly puts it in place for you. Yes.
I encountered an interesting situation. I was trying to type p hat.
Yes.
And I enclose it in dollar signs, and I got a message that's not recognized in the math environment, and then I just typed it without braces, and just put /hat p, and it came out p hat.
So like this?
Yeah, it wouldn't work if I had the dollar sign, so I had to remove the dollar sign.
Well, that's interesting. That's interesting.
You may need to embrace P.
No, I didn't even have to use braces. I could put the braces or leave them out, and it still got p hat.
Yeah. This is very similar. Like if you want a German umlaut over something, like if you want to type, oh, I don't know, Mervius with that, then I would type M, and then if I do a backslash quotation marks, then the next letter will have that will be the symbol to put the umlaut over the next letter, like that. And you don't have, it's not a math environment or anything, so it's probably something similar. It's reading it as a diacritical accent is what it's doing.
Yeah, actually, I got that from, I just searched circumflex. That's what technical hat is.
Yeah.
I just typed in search circumflex, and then I got this whole list of different.
And that illustrates perfectly what I want to illustrate today, which is if you know the basics and how to get started with a minimal document. If you want to know how to do something, where do you go?
The internet.
In Google. Type in LaTex, and then whatever the heck you want to do, and I guarantee you'll find maybe not as efficient a way as you want, but you'll find a way to do it. It's that way with any open source software, which is why it's just so powerful. Now, real quickly.
Oh, I didn't type hat. I just put the caret.
The little symbol, yes. There are going to be many, especially if you're doing a mathematical document, such as a paper or a dissertation or something like that, where you don't want equations within text. You want them on a separate line. Sometimes you want them to be numbered. Sometimes you want them separated at the equal sign, etc. So there are a lot of ways to do that. I'm going to go through these real quickly. This is one, if you just do this little backslash followed by an open bracket and then close it this way, anything that's in here will be put on its own line. Okay, so you don't have to put the dollar signs in that case. That is your math delimiter. What you'll find is it's an equation that has no labeling or numbering. It's just an equation in the middle of text. So I use this one all the time because rarely do I want my equations numbered.
And I think it centers it, doesn't it?
It does center it as well, that's correct. Yeah. Now if you want an equation on a line where it's labeled and numbered, you use the equation environment. Begin equation, end equation. If you want things aligned at an equal sign, like this equals this, equals this, equals this, which is a very nice way to present things sometimes. I wish I could teach proof students to do their proofs that way, but it's exciting. You can use the align environment or the align star environment. The difference between these is the align one will number it, the align star will not number each line. I'll show you an example in a second. So those are the environments for doing equations. So here's an example. I want to put a little geometric series here. So I've got the simple infinite sum of 1/2 to the k. I want to know what the sum is, and there's a nice little formula for it. Again, doing that in Microsoft Word would take a lot of pointing and clicking. That was easy to type, just like that.
How did you get those limits to be above and below the sigma?
Okay. When you do something like this on its own line, okay, that's what's key here. Then when you do the subscript k equals 0, superscript infinity, it will automatically put them below and above the sum symbol. Same thing if you wanted an integral \int, it would do the same thing. If you're in text doing that, you would get something like this. a literal subscript and a literal superscript.
Yeah.
So the difference is this is a float as opposed to an in-text thing.
Now, how did you get that?
How did I get this?
Yeah,
This code right here.
K equals 0,
Oh,
so the
just that second
subscript.
one.
Yep, just this second line right here. So this is the sum from k equals 0 to infinity. Now, notice I've got a very big parenthesis here. I use the command / big L, big left, and then the delimiter I want, a parenthesis. Then I use the frac symbol to make a fraction, and I can nest them because I've got a frac within a frac. Okay. And then I wanted a big right one over here. So I say big right, like that.
I think you can also do it if you do the display style.
It's inline. If you want an inline text, you have to use a display style thing. We'll get to that next time. Yeah. But on its own line, this is all it needs to work. And notice that the equation is numbered. And if it's numbered, you can reference it. I call label series later on in my document. I'll say, if you'll recall from equation 1, I don't have to remember the number. All I say is, if you'll recall from label ref series, it'll calculate the number for me and put it right in the text. So if I stick an equation in before and that now becomes equation 2, I don't have to forget or remember that that's really supposed to be equation 2 now. All the dynamic referencing is taken care of in the compiling process. So that's the equation environment. Now suppose you didn't want to put all that in one line, you wanted to actually put it in 2 lines aligned at the equal sign, which is sometimes very nice. This is the align environment. Okay. Notice I don't put equation around it, I put begin and end align. Okay. The only difference here is I have to tell it where I want the alignment to occur. So I want the alignment to occur at this first equal sign, which is right here. To tell it that that's where I want the alignment, I put in the ampersand right before it. So that tells me to make everything go to that spot right here. So I do my fraction, end the line, and then down here, ampersand equals 2. And it gives me that code right there, or that output. Now, notice at this stage, every line is numbered. Okay, if that's what you want to do, great. If not, use the align star environment. This one right here, and that'll remove that numbering. Okay.
Tom,
Yeah?
from 2 to 3, okay?
Mm-hmm.
Did the program computer give it to you?
No.
You had to put it?
Yeah. Yeah.
Like-
It's really good at typesetting. It really sucks at anything greater than
But
arithmetic.
after you have computer, you have to do that.
Yeah.
And when I was talking about the Excel, like instead of infinity, you had 10 power, okay, from 0 to 10. You have to do the computation.
Right, right. This is not a computational engine at all. Yeah, it's just a
The
typeset.
result is put, okay.
Right. You know, you can interface with things like MATLAB, R, that kind of stuff, and it becomes almost a hybrid computational engine, but its only focus is to typeset that which you have already computed through either hand or some other technology. And it does a great job with it. Okay, so just a little bit more here. I think this is my last slide. I can tell because, well, I have a 38 out of 38. It automatically numbers how many slides I have. That's so cool. Don't be afraid to Google things. All right? That's how you learn this stuff. Many packages exist. Find them. Don't be afraid to experiment. Look, worst thing's going to happen is what?
It's going to say, oops.
It's going to burp and say, error. Just go back and find where the error was. There's always someone out there who knows exactly what you want or what you're wanting to do. You just got to find them and ask them. And let me say as my sort of closing remark, please support the open source software community. Because that community is what allows us to have free stuff like this that can outperform any commercial software out there.
You mean donate money to them?
Well, there is that, but simply supporting and spreading the gospel is what's needed. Look, most open source programmers, myself included, don't do it for the money. They have day jobs, but they do it because they love, I don't want to say to circumvent the man, but they love to get this stuff out there for free to people that don't use it. And so it's, supporting that community is very important.
So I appreciate it.
Exactly. So, with that leaves us off as the basic introduction. Now, next week, I can do whatever you guys can dream up. Some of the stuff I've been doing lately is I make all my presentations now in the Beamer class with LaTex. I'm sorry, these look better than anything I've ever done on PowerPoint, ever. I'm really happy with it. Because I don't have to format it. I just put in my text. It's the ultimate efficient way for a scientist to think. I know what I want to tell you. I want somebody else to worry about how it looks. LaTex is that someone for me. Not to anthropomorphize it, but there it is. I do my Vita in LaTeX now. Looks better than it ever has before. Yes, Art?
Yeah, I have something that really should be done next week, but I want to do it before that. I've noticed sometimes when I'm preparing a document, I'll have letters crowded, and then sometimes I can just go to the edit and then click on move right, and it'll move over. And then it seems like sometimes it doesn't work. So is that actually the way it should be done?
I don't know that I've got a picture of what it's doing to you right now.
Well, I mean, I have a letter too close to some word, like and X, and the X is just
right next to it, as opposed to having a space where it should have it.
Right, and then I would, put my cursor in between the and the X, and then open edit, and then go down to move right.
Well, I'll just hit space bar.
No, well,
scoot it over.
that doesn't seem to work.
That's odd. That's odd. Yeah, I've never run into that problem before. I've run into the problem where I've had things scooted together, but there's space between them and that does it.
Oh,
I don't know.
Seemed like that didn't work, and that's when I went to the edit bar and then down to move right. And then
yeah, so there's an example where you found a solution, but you're still looking for a more efficient solution.
And won't be something that will work every time.
Right.
Well, maybe we can discuss again next time.
Sure. Yeah, my plan is to bring a computer in next time to show you some examples of this in action. This was to kind of give you the basic of what it can do. Next time we'll bring a computer and actually show you the typing and combining process and that sort of thing. Would learning how to do presentations be something that would be interesting to you guys? So we can talk about the Beamer class real quickly. I can show you how to do some basic slides with that. I've got Yelin's graphics problem.
Well, see, sometimes some commands aren't valid in certain environments.
Right. Yeah, that happens sometimes. You kind of have to get to know your environment that you're working in. One example is something called the verbatim environment. Like if I wanted, you notice on a few of these slides, I actually have LaTeX commands typed in. Well, see, if I just typed in / I'll show you. Come on. Okay. If I just typed this in, it would try to read that as a command. Okay? But I don't want it to be a command. I want it to be text, so I have to do something called verbatim. Everything that's in here is not to be read as a command, it's to be read as text. Well, in a Beamer class, there's a weird way to make it work, and I only solved it by Googling. So there's an example of where some things work in some environments and they don't in others. So, any other ideas that anybody would have? You can always let me know. My email is easy, Thomas_Faulkenberry. All right, well, we'll bring a computer in next week. We'll talk a little bit about Beamer, and I'll solve Yelin's pressing graphics problem. Anything else that comes along the way. Well, thank you guys for coming. I hope you can get some enjoyment out of LaTeX, and you're always welcome to ask me if you have questions about it in the future.
Okay.